Hi everybody, it's Joe here. Welcome to the shop. After a few viewer requests, finally got around to making a video about work holding in the lathe and in the mill. What works for me as a home shop machinist, not a production facility or anything like that. But you know, over the years of collecting tooling that works and doesn't work, I've got, you know, pretty fair collection of stuff that I like to use, and I'm going to share that with you in this video, and hopefully save you a little cash, you know, trying things out. Okay, so as far as the lathe goes, my primary general purpose chuck is this 6-jaw, and you know, obviously having more jaws allows you to have less clamping pressure per jaw and still get the same amount of grip as a three jaw chuck. So you can hold things, you know, like with threads, you can hold threads if you're really careful. But to be honest with you, for threads, I would probably use a collet. But this here, you know, if you take 3 of the jaws out, you can have a 3-jaw chuck. For some reason you need that. Or if you take 4 of the jaws out, you can have a 2-jaw chuck. But one of the really useful things on this is if you take all the jaws off, because they're half jaws, you can hold really thin objects up against the face of the chuck. Like if you were going to turn something like a disc or a wheel or something like that, you could hold it right up against the face of the chuck just by the bottom half of these jaws. Obviously I have a 4-jaw chuck as well for this lathe, you know, for holding, you know, irregular shaped parts. And you know, I don't use that too much. Primarily I'm using this one or a collet, because, you know, I don't really turn too much, you know, square stock, or I'm not really, you know, drilling eccentrics and stuff like that. So I'll show you some collets. I've got a set of 5Cs for this lathe. I've got some ERs for this lathe. So we'll show you how we deal with that. Okay, so for collets, I have 5Cs in the ER32 series. What this is this adapts the MT5 in my spindle to a 5C collet. And then here's the draw tube, and here's the little toggle that threads onto the back of it that lets me tighten it up. Okay, so once again, this little piece has a bevel on it, so it self-centers on my lathe spindle on the back end of it here. You can see the tube sticking out. So this thing just screws on here like this. Okay, so when I pull this lever, it pulls the tube, tightens up the collet. It's not as fast as this thing, but I'm not doing any production work here, so I don't need to be changing stuff in the same collet all the time. So as far as 5C collets go, I really have minimal use for them. And the simple reason being that they have a limited range to them. So you need a lot of them if you want to cover a lot of sizes. And, you know, obviously it's, you know, kind of a pain to be dealing with all this other hardware, you know, you got to deal with. So anyways, what I typically use my 5C collets in are collet blocks. And I have two of them. I have a square one and I have a hex one. And if I got to do some quick and dirty indexing, you know, I can throw that in a 5C collet pretty quick and get the job done. So what I prefer in the lathe are the ER collets. And let me move this and I'll show you what I'm talking about with that. Okay, so if I have to use collets in this lathe, I'm pretty much using an ER collet. And this isn't, you know, a shop-built ER collet chuck. I first saw Double Boost making one of these on his channel. And so I said, what the heck, I'm going to try it. So I threaded it, you know, and put the taper in it for the ER. I'm just using the standard nut here. I have a real spanner for this thing, but for a long time I was using the homemade one. These are nicer and they're more flexible because they're more adjustable and stuff. So, you know, typically, you know, you thread this on here, and when I made this chuck, I turned it all on the, you know, once I threaded the back, I never took it off the spindle when I made the front, so everything runs really concentric. So, you know, is like your typical ER collet. What you have to do is, they're double beveled, so, you know, you've got this taper here, but you've also got this taper in the front here, and the nut has a taper in it as well. So this groove here engages a snap ring inside of this nut. So when you snap this in here, okay, it's in the collet, it's not coming out, and that taper inside of there is right up against the front taper of the collet. So you take this and you put it in there, and then here's the spanner for the ER collet nut, and you know, and then you just tighten it up like that. And like I said, if you need to run collets on a lathe, these ER series, I mean, if I already had the ER 32 collets, so I made this chuck as an ER 32. If I was going to do it all over again, I'd buy ER 40 collets and make an ER 40 collet chuck. So the other thing I have is I have an ER 32 shop made collet chuck for the tailstock. And this is good for holding, you know, if you want to hold like a milling cutter in the tailstock and, you know, mill a hole or something in the workpiece. That's what this is good for. I don't use this as much, but it comes in handy when you need it. So, you know, if you got a piece of good steel laying around and a little free time, you can make these chucks with nothing special. I mean, this is a metric thread, so, you know, you got to set the lathe up for metric threading. The headstock thread on this lathe is 2 1/4/8, which is pretty easy to do. So, You know, those are my primary work holding devices for this lathe. I mean, obviously you gotta have, you know, a drill chuck for the tailstock. You gotta have a center, a couple centers. I have like 3 live centers and a dead center. And then I also made, you know, a couple of taper tool holders for like center drills and things like that. So, you know, if you get those things, you know, a good 3 or 6 jaw chuck, an ER collet chuck, and a couple of tailstock attachments, you'll be in good shape for holding a lot of different things on the lathe. So one more thing you might want to get is a good center for your lathe. This one, like I said, is a Morse Taper 5. And then have a dog that I can use for, you know, hooking stuff up and, you know, connecting it. I would usually run a chuck here, or I do have a faceplate. I have turned stuff with this faceplate and the center, but I had to put a couple bolts in some of these holes because this this dog thing wouldn't fit in there, you know, exactly right. But you know, faceplate turning, it's kind of got its limits. Most people just leave the chuck in there and hook a dog on one of the jaws. But can't get it out now. In any case, you know, you get some nice centers, some collets, a good chuck. Be all set for work holding on the lathe. A couple other things you probably could make decent use of is a set of expandable arbors. I've shown these things before in one of my doodads videos. You know, these things work okay in certain applications, but the problem with them is because they're not split on both ends of where you're going to hold the work, when you screw the screw in, you're basically creating a taper. And, you know, it's very slight, but it's there. So these things, I mean, they're good for quick and dirty stuff, but any kind of accuracy, you want to get the other kind, the 2-piece. And I have a set of those on order, and I'll show them in one of my videos coming up when they get here. The big chuck that I have, the 6 jaw, won't go down to nothing, so I have this chuck that I can stick in the jaws, and this will go down to nothing in case I want to turn something tiny. Tailstock die holder. Okay. This part goes into the tailstock, and then this part holds the die. I got recesses cut in here for the 1.5 inch and the 2 inch. This is knurled, so you know when you're doing this, you're powering it, you're holding this, but as soon as you know the torque gets high, you can just let go of it and it will spin on this shaft. I suppose you could put a rod in here and then, you know, have it, you know, hit the bed or hit the carriage, but I like to feel it, and if I'm putting that much force on my lathe, it's not a good thing. So, you know, I tend not to do that to it. If I'm getting that much torque, what I'll do is I'll lock the spindle and I'll put a die stock handle on it and do it by hand. This isn't actually work holding, but this is one thing that I found really useful. It's a turned piece of aluminum that exactly matches the spindle of my lathe. And this is really good when you're turning something that you're trying to get to fit on the spindle, because you can test it with this. You know, it's got a 2 2¼ thread, and it's got the register machined on it. You know, that matches my spindle, and it's very accurately machined, so that if this fits good, I know it's going to fit on my lathe. If you have more than one lathe, you don't need to do that, but I only have the one, so I find that saves you a lot of time. Okay, I'll see you at the mill. Okay, so as far as work holding in the mill goes, I mean, obviously you can clamp things to the bed or the table with those, what do they call them, toe clamps or strap clamps, any of that kind of stuff. I don't do that unless I have to. My primary device on this mill is my vise. Right now I have the rotary table on here, but this vise, it's a swivel based vise, came with the mill, was a total piece of crap, to be honest with you. Nothing was square on it, nothing was true. I ended up, geez, I think one of the first projects I ever did was you know, facing off the base, and then I put new jaws on it, and I had to cut the slides and, you know, the gibs and all that stuff to get it right. And you know, now it's okay. It's not a Kurt. I think it's Chicago Machinery. But you know, this isn't a Bridgeport, so this vise works okay with this thing. I mean, I'm not taking, you know, huge cuts with this, especially when it's up high like that. But you know, this vise is fine. It did require some work. It was, like I said, it was a total piece of crap when I got it. It wasn't functional. I mean, it closed and opened, but there was nothing square on it. It was a total piece of crap. So, anyways, this thing is normally sitting on my table, squared up, you know, trued up, so I can just come over here and throw something in it. The other day I was making some cutters and things, and I had to have this rotary table in here, so that's why this is on here now. Now, this rotary table, I use this for a lot of stuff that I have to hold that's around on the mill, because I can have it like this, you know, and hold something vertical, or I can have the whole table tipped up and hold something horizontal, like, you know, for example, if I had to cut a spline or something, heck, even a gear, I could do it with this. Now, this part of it right here is the stepper motor. What I have on here is an Arduino-based controller, and I can set number of divisions, number of degrees, speeds, arcs, you know, all sorts of stuff like that, and then it'll go. So this rotary table is basically my super spacer, my rotary table, and my indexer, all built into one. And like I say, I mean, you know, I've seen people, they have a rotary table, and then they have a separate spacer, and they have a separate indexing table. And, you know, yeah, okay, I built my little controller, you can buy them, but if you do that, you can save, you know, 2 other pieces of stuff that you can turn into tooling rather than into stuff that you may be using maybe once or twice every couple of months. So that's a story on work holding. Of course, I don't know if you can see them. We got strap clamps here, or toe clamps actually. This one is the 1/2" 13 that goes to the machine, and this set here is 5/16, which I can use to strap things to my rotary table, which has T-slots in it. You can't see them now because the chuck's mounted on there. And one of the things I use to true that up, if I can find it here, is this. And this fits into the Morse taper 3 hole down in the rotary table, and then this part comes through the chuck hole and grips the chuck, so that's how I center the chuck on the table with this mandrel fixture thing. And then this part here, I have a 1/2" stub on the end with an accurately drilled center hole, so I can either use a pointer or a collet to get this thing centered up. And if I really want some accuracy, I can run an indicator around this and, you know, get it down to tenths or whatever you need to do. I've never had to do that, but I can if I have to. I guess that's it for work holding. You know, of course, you know, you need some decent parallels. I've used parallels that I keep on the mill all the time. Now, I don't know if you saw my vise, but I've milled the step on the top of the jaws here. Okay, and this acts kind of like built-in parallels for stuff right near the top. You know, there's not a hell of a lot of gripping power there, but you know, it can be useful. And then these parallels that I keep on the mill all the time, they're about 3/8 of an inch below, so you know, it's just a pretty convenient dimension to have, you know, for the vise. So I keep these here, but I also have a set of regular parallels, and we're kind of getting off the subject here, but these are adjustable parallels. I have a set of those, and then 1, 2, 3 blocks. These can all be used in conjunction with these toe clamps and other hold down studs and things like that to hold your work into the mill, onto the table. I also have a number of other attachments that go with my mill that allow me to hold things. One useful thing is this angle plate. You clamp that down to the table, and then you can get your work up vertical, or if you got a tall piece that you want to mill, you put it up against that. I have a 5C spin indexer, which will accept a 5C collet. Now, I really don't have much use for this thing. I bought this to turn it into a grinding fixture. Or I suppose, you know, if I had a quickie indexing job to do, I'd use that as well. But my primary indexing device is my my Arduino-based rotary table, which I can, you know, basically set up in a few minutes, and you know, I can index whatever. I mean, it just goes by degrees. There's a tailstock for the rotary table as well, if I put it in vertical mode, like if I wanted to cut gears or something like that. Now, no discussion about work holding would be complete without discussing the Venerable strap clamp set. Typically you get one of these when you buy one of those import mills. I have 3 sets. The set on the left is for the mill, which is the standard, what is it, 1/2" studs. But I also have another set over here. It's slightly smaller. I think they're 3/8. Might be 5/16. I have to check. But those fit my rotary table, so I can clamp stuff to that as well. And then I have an extra set over here near my drill press, just in case I have to, you know, hold something down there. So that's about it. That's my take on work holding and what works for me. I'd just like to thank everybody for watching my videos and subscribing. I think got somewhere around 220 subscribers now, and it's just kind of amazing to me that there's 220 people out there that are interested enough in what I do here to watch these videos. But I appreciate it, and you know, if you like this, subscribe and we'll do some more. I got another one coming up. I'm working on tool holding for the lathe and the mill. Got one on my bandsaw welder. I'm going to do some mods on that. I'm making a shop light out of some LEDs for cars. Similar to like a double boost light, but with multiple LED emitters. And there's a little machining involved with that. So that's it. Have a good one. Thanks for watching.